As crypto takes on the global finance market more and more every day, it seems like everyone's turning to blockchain technology. You'll be hearing words like blockchain, mining, and hashing, which probably don't make much sense to you. Unfortunately, if you want to keep up with the new world, you need to know the ins and outs of this revolutionary tech. In today's video, we'll be doing exactly that. So stick around, and you'll know all about blockchain technology. First up, here's the basic idea. Most of the time, your bank acts as the third party when it comes to your everyday transactions. Even though that's been the case for decades, the banking system isn't flawless. You're always dealing with technical issues with your transactions or account hacks. This is where crypto comes in as a better option. It's a decentralized form of digital money that runs on blockchain technology. So, what is a blockchain? Blockchain is defined as a decentralized distributed ledger that records everything concerning a digital asset. The technology is designed so no changes can be made to it, making it a legitimate disruptor for payments and cybersecurity. It's often referred to as distributed ledger technology, or DLT at times. In order to understand blockchain, consider a Google Doc. You make one and share it with your colleagues. What's important to understand here is that the data is distributed and not copied, and everyone has real-time access. The same is the case with blockchain. It's a database where digital assets are distributed instead of transferred or copied, and there's full transparency to the public. Another important thing to keep in mind about blockchain technology is that it stores blocks of data in a chain, essentially forming a chronological single source of truth for the data. The innovation of the blockchain is that it promises security, unlike any other system we've seen before, and generates trust without the need for a third party. Let's discuss the history. Contrary to popular belief, blockchain isn't new technology. The idea for blockchain came about in 1991 as a research project. However, ever since its use in Bitcoin in 2009, the concept has spread like wildfire. The technology has since then been used in the creation of various cryptocurrencies, smart contracts, decentralized finance, and non-fungible tokens that have been introduced more recently. Going forward, blockchain has promising uses for property sales, medical records, and any other industries. Now, we have the types of blockchain. As far as types of blockchain are concerned, there are 4 different types: public blockchain, private blockchain, hybrid blockchain, and sidechains. Public blockchains are open and decentralized. In contrast, private blockchains aren't open. They come with restrictions. Hybrid blockchains, or otherwise known as consortiums, are a combination of both types, with both decentralized and centralized features. And a sidechain, as the name suggests, is a blockchain running parallel to the main one. These help move assets from one blockchain to another. We're discussing the working of public blockchain today. So, how does it all work? To understand the working of a blockchain, we have to look at 3 concepts: blocks, nodes, and miners. First up, we have the blocks. As we talked about before, blockchain technology stores data in chains. On the other hand, if we look at a simple database, the data is mostly structured in tables. Each of the chains consists of many blocks, and every block can be broken down into 3 basic elements: the data in the block, a 32-bit whole number called a nonce, and a 250-bit number called a hash that's linked to the nonce. The nonce is randomly generated whenever a block is created, which then generates the hash. The condition for the hash is that it must begin with a huge number of zeros, meaning that it must be very, very small. The block created is forever tied to its unique nonce and hash unless it's mined, which brings us to our next topic. Next, we have miners. Miners are responsible for creating new blocks on a chain through a process called mining. Well, the hash also contains information regarding the previous block in the chain. With that said, creating or mining a new block isn't easy. Miners have to make use of special software to solve incredibly complicated math problems. The purpose of these problems is to find a nonce that then gives us an accepted hash. Mind you, a nonce is a 32-bit number, while a hash is a 256-bit number. That means there are roughly 4 billion possible nonce hash combinations to go through before you land on the right combination. Once you do, the block is added to the chain, and you also earn some cash. Now, let's say you want to make changes to a block earlier in the chain instead of creating a new one. That'd be an even more complicated process, as you'll be required to not only mine that particular block, but the subsequent blocks as well. In short, when a block is created, it's pretty much set in stone. This way, blockchain technology offers impenetrable security, because generating the nonce hash combination for one block requires immense computing power and time. We'll discuss hashing more later in the video. Mining's also called proof of work. This method of consensus, a way of confirming a transaction, is currently used by Bitcoin and Ethereum, but Ethereum is going to move to proof of stake soon. We'll get to these two later in the video. And now we need to understand the concept of nodes. As mentioned before, everyone has free access to blockchain technology. That also means that no one computer or organization can own a chain. Decentralized is the appropriate term here. The chain is distributed via the nodes connected to it. Now, what are nodes? Any kind of electronic device that keeps copies of the blockchain and keeps the network running. Every node has its own copy, and each participant has its own unique alphanumeric alphanumeric identification number, showing all their transactions. With the chain being transparent, every action can be easily viewed and checked. So, how is a transaction made? Now that we understand the basic concepts that make up blockchain technology, let's look at how a transaction is made. Whenever a new transaction is entered, it's immediately transmitted to a network of peer-to-peer computers scattered throughout the world. This network of computers then proceeds to solve equations to confirm the validity of these transactions. Once confirmed, the necessary information is clustered into blocks. These blocks are then linked together in a chain, completing the transaction. Now, for some more on hashing. We talked about hash before, and we're coming back to it to understand it better. A hash is generated through a process known as hashing. Consider a magic box that also happens to be a math genius. You basically hand over information to the box, and it gives you a hash in return. The process offers many advantages. For one, no one can guess the input. Second, a slight change in the input gives you a whole new output. And third, it's an energy-extensive process, making hackers' lives all the more difficult. Now, for proof of work versus proof of stake. Both proof of work and proof of stake are consensus mechanisms, ways of validating transactions. We mentioned before that mining is called proof of work. It's the original consensus mechanism. However, there are some problems that come with using this way of validating transactions. For starters, proof of work uses a lot of electricity. Second, there's only a limited number of transactions that you can make. The maximum limit with Bitcoin is 7. What's more, transactions take 10 minutes to get through and even longer if the network is congested. Proof of stake was created to solve these problems. This particular consensus mechanism doesn't use cryptographic algorithms for validation. Instead, the process goes through a chosen validator depending on how many coins they have. That's also called stake. The bigger stake someone has, the more mining power, and the greater chance they'll be selected as a validator for the next block. It's different from mining, as participants lock a specific number of coins on the network. There's also no block reward. Some might worry that the system favors those with the most coins, but that's not the case. Other selection methods are also used. Randomized block selection is when forgers with the lowest hash value and the highest stakes are selected. On the other hand, coin age selection is when forgers are selected based on how long they've had a coin in their possession. Overall, the transaction time with proof of stake is faster, and the prices are lower. Finally, we have understanding the keys. Every block comes with two of them. One is the public key, and the other is the private key. A public key stores the user's public information, for example, their web address or their email address. On the contrary, the private key is more like your very own key to a safe. These keys play an important role when you're making a transaction. You can authorize a transaction using only your private key. Once authorized, the block travels with the public key encrypted on it to the other person's address. Now, person B is the only person in the world who can decode the block as long as they have their private key. This way, transactions are kept secure and hassle-free. We hope you understood everything we talked about today. If you've got any questions, shoot them down below. Make sure to leave a like and subscribe to our channel for more videos. We'll see you next time with another video. Bye now.